Hello everyone. In today's lecture we will discuss about derivative. So derivatives are used to find slope of function at a given point. Okay. So as we know, the slope for a straight line are if straight line making an angle of theta from positive x-axis, then the slope can be obtained by m equals to tan theta. And if there are 2 points like x1 y1 and x2 y2 are given, then we can find the slope of a straight line, that is y2 minus y1 upon x2 minus x1. And if there is equation is given, ax plus by plus c is equals to 0, then the slope can be obtained by minus coefficient of x upon coefficient of y. Okay, so that is minus a upon b. Fine. But if there is any other function like circle is given, then how to find the slope for this function? How to find the slope for this function? So for this, we will find the slope of tangent at any point. So if this point is under consideration, we will draw a tangent and we will find the slope for tangent. Find the slope of tangent to the curve at a point, say x1 y1. Okay, so this is how the slope of a function at a point can be obtained by derivative. Okay, another thing, the slope is it is the derivative can be used to find the slope of tangent line, as I told you here. Further, the slope is also called the rate of, sorry, the derivative is also called the rate of change. Okay, we can say like if we consider this definition, that is m is equals to y2 minus y1 upon x2 minus x1, then we can say it is delta y, change in y, upon change in x. Okay, so as the x changes, what are the changes in y? Okay, this is called rate of change in y with respect to x. Now, if this delta x tending to 0, then if this delta x tending to 0, then the limit delta x tending to 0, delta y upon delta x can become the derivative of y, that is dy upon dx. Okay, the derivative of y with respect to x. How to read? We can read it like derivative of y with respect to x. Okay, further, if we move here, how the notations for derivatives. So how we read it? We read it like f prime x. Okay, if y is given, we can read it y prime. If derivative form is given, we can read the derivative of y with respect to x. If it is given that ds upon dt means derivative of s with respect to t. If it is given dx upon dt, that is derivative of x with respect to t. Okay, derivative of x with respect to t in this case. Okay, so these are the notations of derivative of a function y equal to fx. Fine. Further, we move to rules for differentiation. So differentiation is the process of computing derivative of function means the process in which we compute the derivative of function is called differentiation. Further, it can be asked to differentiate a function like y equal to fx. Okay, find the derivative of function like y equal to fx. Find first derivative, that will be f prime x. Find second derivative, f double prime x, and so on. Okay, there are another notations. If it is y, then the first derivative is y1, second derivative is y2, third derivative is y3, and so on. Or first derivative is y prime, second derivative is y double prime, third derivative is y triple prime, and so on. Okay, so these are the some notations, and further we move to power rule. Let us see what is the power rule. Here it is shown that d dx means derivative with respect to x of x to the power n is n x to the power n minus 1, where n is any real number. Okay, so if we find the derivative of x to the power 3 according to this rule, it will return, just see 3 will become in the front, so 3 x to the power 3 minus 1, it will return 3x square. Okay, now let us see another example. See, d over dx of x to the power 5 by 2. Now what will happen? See, 5 by 2 will come in front, x to the power 5 by 2 minus 1, it will return 5 by 2 x to the power 3 by 2. Okay, in third example, let us see d dx of x to the power minus 3. See, minus 3 will come in front, x to the power minus 3 minus 1, it will return minus 3 x to the power minus 2. You can simplify it like minus 3 upon x square. So this is how we have to differentiate. This is how we have to differentiate by using the power rule. Okay, let us see another example, the derivative of x to the power 1 or derivative of x. So by applying the power rule, we will find 1 in the front, x to the power 1 minus 1, so it will return 1 into x to the power 0. So any the power 0 of any non-zero number x to the power 0 will become 1. Okay, so this is how we can find the derivative of x. So you should remember that derivative of x always 1. Okay, derivative of x is 1, and for another functions like x to the power n, you can find the derivative like this. Okay, further we know we are doing for this, it is constant function. So for constant function the derivative is 0. The derivative of constant function is 0, like derivative of 5 is 0, like derivative of 10 is 0, like derivative of some a where a is constant is 0. Okay, so derivative of all the constant numbers is 0. You should remember that derivative of constant term always 0. Further, if this constant comes alone, if this constants come alone, it will become, the derivative of constant will become 0. But if this constant come with a function, if this constant come with a function, then this function will save this constant, and this function will save this constant. So c will be out, only fx will be differentiated. So let us see some example. D over dx of 5x cube. Okay, so in this example 5 is constant and x to the power 3 is function. So x to the power 3 will save 5. How? Let us see. So 5 will be come out, So 5 will come out, and differentiation of x cube will happen. So 5 differentiation of x cube will return 3x square. So final answer, what is the final answer? Final answer will be 15x square. Okay. See one more example. One more example, if it is written that differentiation of under root 2 x to the power 3 by 2. Okay. How to do? Root 2 is constant number. Root 2 is constant number. So root 2 will become out into, it will return differentiation of x to the power 3 by 2. So under root 2, 3 by 2, x to the power 3 by 2 minus 1. It will return under root 2 into 3 by 2, x to the power 1 by 2. So this is the final answer, but if you want to solve it, you can write it like 3 by 2 under root 2x. Okay, so this is the final answer. Okay, so this is how we will differentiate we will apply the power rule, and we will find the differentiation of constant function. Further, the sum and differences of functions, if the two functions are in the sum form, the differentiation will takes separately on them, and if they are in difference form, again the differentiation will be taken as separately. Further, if we have to find the derivative, let's see some examples more. If we have to find the derivative of 7 as it is constant, so f prime of x will be 0. Again, y equal to minus 3, it is again constant. So y prime is will be 0, where y prime is the first derivative of function. Further, again this is example, we have to find the derivative of x cube by power rule, it will return 3x square. The solution of x to the power 9 will return 9. The differentiation of x to the power 9 d over dx of x to the power 9 will return 9 x to the power 8. Now differentiation of x to the power 100 will return 100 x to the power 99 by power rule. Further, we move to this problem, differentiation of 5x to the power 7. It will return 5 into 7x to the power 6. 5 into 7x to the power 6, that is 35x to the power 6. So we stop here in this video. Further, in next video we will discuss more about differentiation, and till then be safe at home, and please like, share and subscribe my channel Padhai Likhai with Saurabh. Thank you.